Here we are discussing a problem which was asked in the ISI JRF entrance exam in the year 2020. This question was asked in the MTA paper, which is the first paper. It's a problem from complex analysis. Let's first suppose let's discuss the question. F is a function which is an entire function from the complex plane itself, and an entire function means it is an analytic function everywhere on the complex plane. That is, the function is analytic everywhere in the complex plane, and an additional condition is given. Given that limit mod z tends to infinity, f of z by z is equal to 0. So what we have to prove is that f is a constant function. So let's use the given facts. Given that f is an entire function, so f has a Taylor series expansion about every point in C. From the Taylor's theorem, we know that we can expand f as a power series which only involves positive powers about every point in the complex plane, because it is analytic everywhere in the complex plane. So let us write the power series expansion, the Taylor series expansion of f of z about the point z not equal to 0, which is let's take the coefficients as a naught, a1, etc. So we can write f of z equal to summation equal to 0 to infinity a n z to the power n, which is while we expand it, it turns out to be a naught plus a1 z plus etc. So let us consider the quantity f of z by z, which is equal to a naught by z plus a1 plus a2 z plus etc. Now let's apply the limit mod z tends to infinity on f of z by c. So limit mod z tends to infinity a naught by c plus a1 plus etc. While considering that, we can see that if a1, a2 etc., that is an for n greater than or equal to 1 is non-zero, then the limit will approach infinity because mod z is tending towards infinity. So we cannot have a1, a2 etc. as non-zero numbers. So a1, a2 etc. has to be 0. That is, for all n greater than or equal to 1, an has to be 0. So what we get here is that f of z cannot have the terms of z, z square etc. So f of z has to be the term which does not involve z, which is a constant term. So f of z has to be equal to a naught, which is a constant function. So that is what we have to prove, and that is the solution of this question.